主题是用 CFC 探讨单一住宅内部空间流体活动。
Good afternoon, professors and classmates. Welcome to my presentation. My name is 112鍾, and my advisor is Professor Shih-Hao. And today, the topic of my presentation is about exploring fluid flow in the interior space of one single dwelling by CFD. And now, this is my outline. It can be divided into 4 parts. The first part is introduction, and second is materials and method, and third is result and discussion, and the last is conclusion. Now, let's go to introduction. First of all, it's important to mention that Taiwan is in the subtropical climate with its high heat and humidity. Means that using air conditioner to keep indoor space comfortable comes with a high energy consumption. Therefore, the natural ventilation in the building can do, first, adjust the temperature, and second, provide the fresh air, and third, reduce the concentration of pollutant to achieve living environment comfort and building energy saving. Our experiment process can be summarized as follows. First, we focus on CFD analyzing for one single dwelling with natural ventilation. And next, we evaluate the ventilation performance and make improvements. And finally, our goal is to achieve both comfort and energy efficiency. And let's go to materials and methods. Let's talk about our studying method and the analysis process. There are 4 general methods for studying the ventilation in buildings: field observation, multi-zone model, computational fluid dynamics, and wind tunnel. In this study, we use computational fluid dynamics. It's a technology that uses numerical calculation to simulate the physical phenomena such as fluid flow and heat transfer. In here, we can see the analysis process of entire simulation. Preparing model, setting fluid condition, building boundary condition, establish computing goals, run the calculation, and post-processing. And the CFD simulation process involves indoor space grading based on continuity, Navier-Stokes, and diffusion equations. Using numerical method to calculate with appropriate boundary and initial condition to get the velocity, pressure, and concentration from simulation. So in the first step, we're building a model. And this building is a 3-story detached house with an American style and green energy features, using natural ventilation designed to provide the fresh air and reduce the pollutant in the interior space. And natural ventilation mainly relies on the outdoor wind, make the air flow to keep living environment comfort and to achieve the purpose of building energy saving. And the 3 pictures show the 3 aspects with the whole view of the building. Its dimension is 13 meters long, 40.5 meters wide, and 13 meters high, with a courtyard of 56 times 56 square meters around the building. And the building is symmetrical on both sides and features vibrant contrasting colors. The roof is red, and the window frames are green, and the other parts are white. And those color scheme emphasize the building to create a bright, fresh atmosphere. And in building materials, stone is mostly used for the appearance, such as slate, cobblestone, marble, and granite. And the inner structure mostly made of wood like oak, maple, beech, and pine. And then we set in fluid and initial condition, and building boundary condition with appropriate volume. We set a volume flow rate of 0.3 cubic meter per second in the entrance. And then we set a static pressure of 1 atmosphere at the outlet, and define the velocity, pressure, and concentration from simulation. We select the parameter we need, like pressure and velocity, and run the calculation to achieve the convergence, and finally get the result. And let's go to result and discussion. So, we built a 3-story detached house. By using this analysis method, we can find out how the flow moves and get the flow patterns. In figure A, show the color range of indoor velocity. We focus on the first floor. As we expected, the red one is the strongest at the entrance, and then gradually become weaker, turn blue to the back. And as you can see, the 3 floors all have the same result. The red one is the strongest at the entrance, and the blue one is the weakest in the edge. In here, we can observe the flow patterns and the velocity component, which is strongest at the inlet and then gradually decrease to the back, then forming a vortex. Corresponding to the XY chart, X axis is the length and Y is the velocity. And you can see the line trend is continuing downward. In here is the strongest at the inlet and gradually decrease and finally dropping at the end. And let's go to conclusion. So, after the experiment, we can get a strong, solid conclusion that in this study, we use CFD numerical method to simulate and predict the velocity, pressure, and concentration of distribution of ventilation in buildings. And we optimize the CFD model to enhance the prediction accuracy. And the result can provide the designer as a planning reference and architecture design. And this is the end of my presentation. Thank you for your attention.